This video looks at introducing the roots of polynomial equations. So when we solved quadratic equations at GCSE, we found the values of x that fitted the equation. These values of x are called the roots of the equation. So for example, we would have had x squared plus 3x plus 2 equals 0. Then by factorising, it would have given us x plus 2 times x plus 1 equals 0. And we would have solved that and found that x equals minus 2 or x equals minus 1. So our roots of x squared plus 3x plus 2 equals 0 are minus 2 and minus 1, since these are the values that x can take. We're going to look more in depth at the connection between these roots and the equation it came from. So looking at your homework, you should have got results like this. So these were the 5 questions. So for each one you had the factors, the roots, the sum of the roots and the product of the roots. Looking carefully at these, if we start with the product of the roots, for the first 3 equations where you've got 1x squared, you should have found that the product of the roots matched the constant term at the end. So the plus 15 matches the plus 15, the minus 12 matches the minus 12, and the plus 28 matches plus 28 there. For the sum of the roots of these first 3, you should have found that it was the negative of the coefficient of x. So where you had a plus 8x, then the sum of the roots was minus 8. When you had a minus 4x, the sum of the roots was plus 4. When you had minus 11x, the sum of the roots was plus 11. With the bottom 2, we've now got coefficients of x squared, and we can extend what we've found for these into these ones. So if we look at here, we had minus 6 for the product of the roots, when we've got actually a minus 12 as our constant term, but we have 2x squared. So if we do minus 12 divided by 2, we will get our minus 6. Product of the roots for this last one was minus 6 over 10, or minus 0.6, whereas our constant term is minus 6, but our coefficient of x squared is 10, and negative 6 divided by 10 will give us the product of the roots that we got. So we can work out the product of the roots as the constant term divided by the coefficient of x squared for whatever quadratic equation we have. If we look closely at the sum of the roots for the bottom 2, we can see the link is there as well, in that it's our negative 5 becomes our plus 5, and we divide it by the coefficient of x squared. And then we've got our negative 17 over 10. So the sum of the roots is the negative of the coefficient of x divided by the coefficient of x squared, or minus b over a. So we can extend what we found here to look at cubic and quartic and higher order equations. We will generally be looking at quadratic, cubic and sometimes quartic equations. Another thing to note is that the number of roots of an equation matches the order or the degree of the equation. So if you've got a quadratic, you will, with an x squared, so a degree or order 2, you will have 2 roots. A cubic, which involves the x cubed, will have 3 roots. Quartic, 4 roots. One thing to note, though, is that these 2 roots may well be complex or repeated roots, the same with the cubic. So any repeated roots or complex roots will be in those number of roots. So this is the total number of roots, be they real roots, repeated roots or complex roots.